In our final lecture, we will show how to add our own classes in Visual Basic.
The next question we need to ask is, how do we go about adding a class to a Visual Basic project? And it's pretty simple. If we want to add a class, we would need to go to the project menu in Visual Studio, and then we would click on Add Class. From there, we would just select the name of our class so we can choose whatever we want, and then we would just click on Add. That's all we do. Once we've added the class, Visual Studio will actually create a .vb file, and the name of the class is going to be the name of the file. So like, for example, if you have a class called myClass, then your file is going to be myclass.vb. Let's talk about a very simple example. Let's say we want to create a class that describes an employee. So we can go into the project settings, go into add class, and then put the name employee. And then what we would do is end up creating a new class file. This would be called employee.vb. We can open up that file and we would see that it would give us the following code. So we would just have public class employee. There'd be nothing but afterwards except for end class, and that's fine because we still need to add attributes and sub procedures in here, but it'll give us at least the class template where we have public class employee and end class. We next need to add attributes to our class. So we're just basically going to be declaring variables in here. Now, in order to add an attribute to a class, we have to state the modifier, then the attribute name, and then the data type. We have to have all this information. Now, the modifier is either going to be public or private. So just as a review, public would mean that we can directly access the attribute, and private means that we cannot directly access the attribute. In most cases, you're going to be using the private modifier for attributes. Can you use public? Yes, you can, but it's not a good idea because a lot of times we don't want to directly access an attribute. We want to be able to indirectly access it by using the different sub-procedures. Let's go back to the clock class as an example. The hour, minute, and second should be set to private. If we make them public, that means we can directly modify them as we see fit. Like, for example, we can say that the minute for a clock is 100, which is not true. The minute can only be between 0 and 59. So if we make it public, we could allow those types of values, which we don't want. Instead, we want to be able to control the value of the attribute by using the sub-procedures. So that's why it's usually a good idea to make sure that your attributes are private and not public. Here are some examples of including attributes for our employee class. So in this case, we have private string name as string. So that's going to be the name of our person. We have private double hours as double. So this is going to store the hours that an employee works. And then we have private double pay rate as double. That's what DBL stands for, by the way. And that's going to contain the pay rate for the employee. Now you may be looking at this and going, wait a minute. Why are we starting each of these attribute names with underscores? Well, first of all, we are allowed to do that because if you remember, an identifier can have letters, numbers, and underscores, and it can start with a letter or an underscore. So this is legal, but the reason why we do this is it's actually widely accepted that for private data members of a class, we would start with an underscore. Are you required to do that? No. You're not required to do it, but it's the norm that private data members in a class would start with an underscore. That way you can distinguish between a private data member and maybe another variable or parameter in your class. Now, with each attribute in our class, we can set up what's called a property for that attribute. The idea with a property is it allows us to define get and set operations. Well, what are these? The get operation allows us to return the current value of an attribute. And the set operation allows us to assign a value to an attribute. And what's nice about the set operation is it does give us control over what can be stored in the attribute. So going back to our clock example with the minute, if we could directly access the attribute, we can set it whatever we want. But by using a set operation, we can say, or at least make sure, that the value of minute is between 0 and 59. And we can make sure we include things to prevent it from going less than 0 or 60 or above. So what is nice about this is, in order to interact with the attributes, we would use the property to indirectly access and modify the attribute. This is very similar to the get and set methods in Java, if you're familiar with the Java programming language, where we would have an attribute that's private, but we can make methods that are public that allow us to return the value of an attribute or be able to set the value of an attribute to something. This is the same thing, it's just we're using the property setup instead of just creating our own sub-procedure methods. Could you create your own get and set sub-procedures? Yes, you can do that, but we can use the property structure here as well. And we should mention, because we want to be able to access these operators, the properties are always going to be set to public. Here's an example of a property where we're trying to define the get and set operations for our pay rate variable. So we see at the top we have public property pay rate as double. So what we're doing is we still have public and property, that part should be given. And we can think of the name of the property as almost like another variable, where it's actually going to directly work with the attribute. So here we have the name pay rate up here, and we say the type of it's going to be double, so the type of the property has to match the variable that we're working with. And we see that we have our get operation defined here. So we see that we have get and end get, and we see here that if we use the get operation, all we're going to do is return the value of our double pay rate. So whenever we so the idea with this is, when we actually see some examples later on, whenever we use the word pay rate, it's just going to give us the value of double pay rate. So we're indirectly accessing our attribute in this case. And then we see that the way we would define the get operation is we would have the word get, and then we would have something in the body, and then end get. Now we could do more with the get operation if we want to, but usually it's just going to be returning the value of the variable, and that's it. And then we see that we have the set operation defined right here. So we see that we have set, and then in parentheses we have value as double. So think of this as basically a sub-procedure or a method, where we have set, and then in parentheses would be the value that gets passed. So what would happen here is, as we'll see later in our code, whenever we say pay rate equals something, whenever we assign a value to our pay rate property, that's the same thing as calling the set method and passing the value that's assigned as a parameter or an argument. And then we see that it ends with end set at the bottom, and then what we have inside would be what happens when we try to assign a value to our pay rate. So we check to see if the value is greater than 0, then we would say that the pay rate attribute should be that value. But if it's not greater than 0, so if it's 0 or negative, then we're just going to say that the pay rate is 0. So as we said before, what's nice about this is it gives us control over what actually gets stored in pay rate. So this prevents a person from assigning a negative value as a pay rate, because let's face it, you're not going to pay your employer to work for them. It's the other way around. You should be getting some type of payment. So here we make sure that we have valid numbers for our pay rate.